In this video, I'm going to talk about numerical models. Biomechanics is all about the mechanisms of the body and looks at the forces that are acting on it and the results of these forces on the body. Biomechanics is broad. The numerical elements are also very broad. There are two different kinds of numerical analysis. Biomechanics looks at a range of things. The two categories are motion kinematics, such as speed, velocity, acceleration, distance, etc., which is all about the motion of objects and bodies, looking at the change in position, while kinetics is all about forces and the causes of motion, looking at the different forces that are involved in movement. There are different kinds of forces, such as air resistance, friction, and gravity. An important difference between the two is that kinetics takes into account the mass of a person or an object, whereas kinematics doesn't take into account the mass of an object or body and just calculates the position over time. So there are different kinematics: linear motion, curvilinear motion, angular motion, and general motion. These are all different ways and angles at which something moves. Linear motion means in a straight line, curvilinear motion is in a curve, angular motion is around an axis, and finally general motion is linear and angular motion put together in a movement. So projectile motion is the movement of an object through the air due to the acceleration of gravity. For example, when a basketball is thrown or projected into the air when taking a shot, the object is called a projectile, while the path it travels in is its trajectory. There are two different kinds of kinetics, which include linear kinetics and angular kinetics. Linear kinetics include force, gravity, mass, and weight, whilst angular kinetics is to do with movements and levers. I'll talk about these in greater depth later on in the video. So, numerical models are created via analysing the numbers, techniques, statistics generated from elite or successful performance, seeing what they did during their performance. In the case of basketball, you'd look at the top rebounders in a team and find out how much force they generate and the height of their jumps, and this could be the perfect model. The perfect model is a descriptive term to relate what the optimal way of achieving something is. For example, in a basketball layup, the perfect model may be what is the perfect timing to take off into the air. You'd do this by looking at the best players in the world and seeing what angle they take off when they leap into the air that forms the perfect model. Or you'd look at maybe the optimal velocity needed when approaching the basketball to do a layup. Also, to generate the perfect model as well, looking at elite performers, there are other ways of doing this, which could be through literature sources, looking at other research and the findings from it, and you also may want to collect your own data to get an insight from a person's own perspective. Force. So there are 5 different effects of force on an object. These include acceleration, deacceleration, rest to motion, change direction, and change shape. Acceleration. So a force can cause a moving body to accelerate. For example, in a basketball game, a person who's performing a layup will speed up and accelerate as they approach the basket. They accelerate firstly so that they have more momentum to power them up higher when they jump. Another example of acceleration in a basketball game is when a person is running and dribbling down court. They'll be accelerating, or if a defender is threatening a player, they may accelerate to get away from them. Deceleration, a force that can cause a moving body to decelerate. So a force that can cause a moving body to decelerate. For example, in basketball, when a player catches the ball, they will apply a force to the ball to slow it down and decelerate it. A player in basketball will also decelerate maybe when running, such as if a player is sprinting to go and get the ball that's a loose ball, but if someone from the opposition gets the ball before they do, they may decelerate and slow them down into a jog opposed to the sprint. Rest to motion. So this is when a stationary object is made to move. A force can cause a body that is at rest to move. For example, in a basketball, when a tip-off occurs, to start off the game, a tip-off is happening, the ball is stationary in the referee's hand and is at rest. The ball is stationary. The official then throws the ball into the air, causing the object to move, so it therefore goes from rest into motion. Changing direction, change direction, this is when the ball changes direction. A force can cause a moving body to change direction. For example, in basketball, when a ball is travelling through the air and a player makes a block, the ball will, as a result of hitting the player, change its direction. And then finally, change shape. A force can cause a body to change its shape. For example, in basketball, when a player catches the ball in their hands, their skin and hands will change shape as the ball hits their hand. The ball will also slightly change shape, but hands will be more affected than a ball. There are 3 different types of motion: linear, angular, and general motion. Linear motion is when the person's body or object all moves in a straight line and in the same direction, while angular motion is when a body part moves in a circular motion and rotates. The contact point becomes the axis and the body rotates around the axis point. General motion is a combination of both linear and angular motion. In basketball, running in a straight line for a sprint is a combination of both linear and angular motion. Running is linear motion as the person is running in a straight line and their torso is linear. Running is also an example of angular motion as the joints are moving angularly and the joint at the shoulder is rotating at the axis, as the individual is using their arms to rotate them to run them faster. That's when the axis is moving, and that's where the rotation is. Another example of angular motion is a basketball rotating in the air if the player has put backspin on it. It is angular motion as the ball is rotating around an axis point. An example of general motion is cycling. Here there is linear motion of the torso and angular motion of the legs when the person is cycling as the person pedals. In nearly all sports, we have to overcome inertia to create movement. For example, a tip-off in basketball to start the game. The ball starts off stationary and the ball is reluctant to change. The ball starts off stationary as there is a reluctancy to change, and it's only if someone applies a force to the ball that the inertia is overcome. Different sizes and masses of balls can have an effect on inertia. A small ball that is of a larger size and mass has a bigger inertial value than a ball that has a smaller mass. To make motion happen for the ball, the one with the bigger mass, so to make a motion happen for the ball with the bigger mass, a larger force is required to be applied on it. This is because it has to overcome a bigger resistance, as it has a greater reluctancy to change. So, Newton's 3 laws of motion. So the first law is known as inertia. Inertia means reluctancy to change. An object or basketball is either at rest and is therefore stationary, or is moving at a constant velocity. The object does not want to change motion and will continue in that state unless acted upon by an external force. A moving object will be travelling in a straight line with a constant velocity and will only change movement if a force is applied. For example, in basketball, example would be when there's a constant velocity may be shown includes when an individual or player is running down court. They will have air resistance acting upon them, and that is being balanced by friction, meaning that a player is travelling at a constant velocity down court. There is a 0 or a naught net velocity, showing that their velocity is constant. The second law is known as acceleration. The acceleration you have is proportional to the size you apply, so the force causing it and the acceleration takes place in the direction in which the force acts. This law is centered mainly around the way at which size and direction of a force determines the acceleration. The acceleration takes place in which the direction the force acts. The acceleration of a basketball is made by a net force that is directly proportional to the magnitude of the net force, in the same direction as that net force. So the more force that is applied, the more acceleration that occurs. A small force that is applied will result in a slow acceleration, while a larger force being applied will lead to larger acceleration. Acceleration is force times mass. For example, in basketball, when a player is performing a box out and rebound during this, the player has to launch themselves into the air. Acceleration is involved in this action as one force is larger than the other. As they are jumping up into the air, there are unbalanced forces, as their reaction force is pushing them up into the air, allowing them to get height, while gravity is pulling the person down to the ground. But because the reaction force is greater than the force of gravity, the player goes up into the air and is able to catch the high ball. Acceleration is occurring in the direction of the larger force, and the direction the player is going up, and so is vertical forces. The final law is action and reaction. This is the third law. This is all about reactive forces. This law is centered around the idea that to every action there is an equal and opposite reaction. It's all about the force applied being the same force that is applied back. There is equal and opposite reaction occurring. For example, in basketball, when a player is doing a bounce pass, the player is applying a force on the ball, sending it towards the ground. The ball then bounces off the ground, with the ground hitting the same force the person applied back, resulting in the bounce. Or when a player takes a shot and the ball hits the backboard and bounces off, the force is applied from the player into the ball. It then hits the backboard and bounces from the board as the board applies the same force back. So eccentric and direct force. Eccentric force is when a force is applied outside the centre of mass and is therefore applied away from the axis of rotation. This results in the ball rotating via angular motion. An example of this is in table tennis if a player puts spin on the ball, topspin or backspin. Whilst direct force occurs when a force is applied exactly in the centre of the ball and directly through the centre of mass. The ball wouldn't rotate in the air and would therefore travel in linear motion, which is essentially a perfect straight line. For example, a penalty taken in football, when the ball is kicked, the force is applied directly into the centre of the ball, making it travel with no rotation. Momentum is the amount of motion that something has. It's the amount of motion in a moving object and is the product of mass and velocity the object is travelling at. Momentum is related to Newton's first law. It is the trend that a moving object will continue to move once the momentum of it has begun. Once an object has built up momentum, it will essentially continue at the same velocity until external forces act upon it. The longer the force is applied for, the greater the force and therefore the greater momentum. Momentum is measured in kilograms per meter per second. For example, in basketball, when a player is wanting to do a long pass down court, they would want to get a lot of momentum on their pass so that they can travel a long distance. A long pass would include what's known as a baseball pass. This pass involves bringing the ball from behind the head, then throwing the ball hard. This pass would be used opposed to the one from the chest, as from the chest momentum can't be gathered, whereas the momentum is being gathered from the action from behind the head and bring it behind the head all the way through until the ball is released. In relation to jumping for a ball in basketball during a rebound part of a box out and rebound, if a player wants to jump higher to get the ball, they would increase their vertical velocity as they can't change their mass. To increase velocity, the time, how long for, and the size of the force applied would need to increase. As velocity affects momentum, the momentum would increase, enabling a person to jump higher. The longer the force applied for, the greater the force, and therefore the bigger the momentum. Impulse is another way of describing force. Impulse is the change of momentum of an object when the object is acted upon by a force for a period of time. It is the effect of a force acting over time. Impulse is calculated via force times time, essentially how much force by how long the force is applied for. For the longer the force is applied for, the greater the force and the bigger the momentum. Impulse is a vector in the same direction. The impulse applied to an object makes an equivalent vector change in its linear momentum and then in the same direction.